Hello everyone, this is the second video on the concept of polynomial. In this video, I will tell you the relationship between the degree and the coefficients of the polynomial. So at first, about the degree of a polynomial. So the highest power of variable is the degree of the polynomial. If you observe this example, here highest power is 4, so the degree of the polynomial is 4. So you can divide your polynomials based on the degree. First of all, the linear polynomial in which degree is 1. For example, x plus 2, here highest power is the 1, so it is a linear polynomial. Next is the quadratic polynomial in which your degree is 2, means highest power is 2. For example, x square plus 5x plus 7. And next is the cubic polynomial in which degree is 3, it means the highest power here is 3. Next, we having the coefficient of a variable. So the constant number with the variable, it's called its coefficient. If you observe these two examples, the number with x square is 2, so the coefficient of x square is 2. Same way, the coefficient of x here is 5. This 3 is called the constant term. Same way, in the second example, the number with x square is 3, so its coefficient is 3. For the x, it's minus 2 and 4 is the constant term. And one more thing you have to note down, that the number of zeros of a polynomial cannot exceed its degree. Means if your degree is 2, then you having maximum 2 zeros. If your degree is 3, you having maximum 3 zeros. Now we go the concept. Concept is relationship between the zeros and the coefficient of a polynomial. Zeros you are well aware, as we have discussed in the first video, the number which gives 0 when placed in place of the variable, that is called the 0, and coefficient, as we have discussed in this video, the numbers with the variable are called the coefficients. So one by one we'll discuss. First, for the linear polynomial. The linear polynomial, the standard form is ax plus b. Because highest power is 1 here, so this is the standard form for the linear polynomial. So the relation between 0 and the coefficients is that your 0 is equals to minus b upon a. Let's take an example. Suppose this is the polynomial 2x plus 3. So a here is 2 and b here is 3. So the 0 for this linear polynomial is minus b upon a. It means minus 3 upon 2. So it's very simple to find the 0 for a linear polynomial. Next is for the quadratic polynomial. The standard form of the quadratic polynomial is ax square plus bx plus c. So in this case, we having the coefficient for the x square as a, for the x as the b, and for the constant term, that is the c. So in general, alpha and beta, you are familiar with these two representations, alpha and the beta. These are the Greek symbols. So we use alpha and the beta to represent the two zeros of the polynomial, because for a quadratic polynomial we can have maximum 2 zeros. So one zero we take as the alpha and other zero we take as the beta. So the relationship between alpha beta and this coefficient is that the sum of zeros, means if we add 2 zeros, alpha plus beta, this value comes equals to minus b upon a. It means coefficient of x upon coefficient of the x square. Next is the product of zeros. It means alpha n into beta. In this case, if we multiply, we get the value equals to c upon a. Means constant term divided by the coefficient of the x square. So let us take one example. So question you get in this form. Find the zeros of the quadratic polynomial x square plus 7x plus 10, and then you have to verify the relationship between the zeros and the coefficient. So first of all, we have to find the zeros. So for finding zeros, we will use our middle term splitting method. This you are familiar because you have done this in the class 9th also. So first of all, a into c means 1 into 10. That is 10 itself. So factor of 10 are 2 and the 5. So we can split 7 as x square plus 5x plus 2x plus 10. So we are splitting the middle term. That's why this is called your middle term splitting method. Now we will take common from first two term and then common from last two term. From first two term we have x as a common, we get x plus 5. Here we can take 2 as common, so we get our x plus 5. So x plus 5 is common again. So x plus 5 is the first factor and remaining x plus 2 is the second factor. Equating this with 0 and this with 0, we get x equals to minus 5 as the first 0 and x equals to minus 2 as the second 0. So this is our alpha and this is our beta. Now second is the work of verification. For verification, first of all, sum of zeros we have to verify that sum of zeros is equals to minus b upon a. It means alpha plus beta is equals to minus b upon a. This we have to verify. So placing alpha is minus 5 and beta is minus 2, and in this case our b is 7. So we get minus 7 here. A is our 1. So after solving further, minus 7 equals to minus 7. So sum of zeros equals to minus b upon a is verified here. Same for the product of zeros, means alpha beta must be equals to c upon a. Means minus 5 into minus 2 equals to constant term c here is 10. So 10 upon 1. So 5 to the 10 and minus minus plus. So 10 equals to 10. So this verify the relationship between the zeros and the coefficient. Let's take one more example. Here the polynomial is 2x square minus 8x plus 6. So first of all, middle term splitting. So 2 6 are 12. So factor of 12 are 2, then 2 and the 3. So 3 to the 6 and 2. So 6 plus 2 can give us the 8. So we can split minus 8 as 2x square minus 6x minus 2x plus 6. Now from here we can take 2x as the common, so we get here x minus 3. Here we can take 2 as common, so we get again x minus 3. So x minus 3 as a common, 2x minus 2 in the second bracket. So this also equals to 0 and this also equals to 0. So x here is 3, that will give the alpha, and in this case x is your 1, that is gives you a beta. Now same the verification work. Alpha plus beta is minus b upon a. So 3 plus 1 equals 2. B here is minus 8 and a here is 2. So after cancellation we get 4 equals to 4. And alpha beta equals to c upon a. So 3 into 1 equals to 6 upon 2 because c is our 6 and a is our 2. So after cancellation here 3. So 3 equals to 3. So this verified the relationship. This relationship that sum of 0 is minus b upon a and product of 0 is c upon a. This you have to memorize, and the way of solving I have told you. So this is a very important concept for exam point of view. So hope you people are able to understand. Thank you.